experiment assignment on the web.
Okay. Cool. How long have you been doing Python?
I don't know, like almost a decade? I learned it, yeah, almost a decade, I guess.
Great. Do that. All right. We'll go ahead and get started. All right. Good morning, everyone. We are going to get started now. I just want to welcome everyone to the first talk of the morning. And this is Jessica. She's from Yelp. She's been doing Python for over 10 years and lots of experiments on the web. So she's going to go ahead and get started now. Go ahead and give her a round of applause.
Hello, can everyone hear me? Sounds like you can. Sweet, so my name is Jessica Stringham. I'm going to be talking about experiment assignment on the web. If you have any questions, there should be some time at the end. Otherwise, you can find me around the conference. I'll be at the Yelp booth. You can also find me on the internet. And if you go to my GitHub, I have like some supplementary materials on there too, if you want to check it out. My GitHub is just Stringham with 3 S's. So this talk is about implementing random assignment for experiments on the web, such as A/B tests. But this is how I describe it to friends. So first, let's get a show of hands. How many of you have heard of A/B testing? Oh man, that's so many hands, amazing. Great, so this talk is going to be about how do we make a decision given a visitor to show you A or B. And you might be thinking, that seems pretty simple. Why not just use random.choice? And I'm going to say we can do better than random.choice. It helps to learn a couple of rules first, and it gets a lot more complicated when we try to scale it up and try to run more than one experiment at a time. So a little bit about me. I work at Yelp. Yelp's mission is to connect people with great local businesses. To do this, we run lots of experiments. So for a few years, I helped run experiments. And then more recently, I worked on an experiment assignment library. And in doing this, I worked with a really cool team. I learned a lot from people at Yelp who were running experiments. And then I also did my team did some research about how other people are solving these issues. And we brought this all together to build our experiment assignment library. And I also wrote this talk based off of that information. So I have to say thank you to all those people for helping me with that. So here's the plan. I'm going to start by giving some context and kind of introduce the rules of experiments on the web in general. Then I'm going to show how to implement random assignment from scratch. Then I'm going to show assignment in practice. And this is the part where we start scaling it up, trying to run more than one experiment, which you often need to do if you're actually trying to run experiments. OK, so let's start with experiments on the web. So we're going to start by coming up with some design, so kind of sitting down and thinking about what we want to do. Then we're going to write the code. That's implementation. Part of that is implementing experiment assignment. And then we're going to wait, collect data, and run our analysis and stuff. And I also want to introduce my first rule, which is to follow your experiment design. All that means is that with these steps, all of them kind of need to be in order, be in sync. Otherwise, it kind of all falls apart, and the conclusions we make are incorrect. OK, so let's start with design. So I'm going to have this feature. This is the list of reviews. This is my review of Bob's Red Mill that's down in Milwaukee. So you guys want food? Yeah, Bob's Red Mill, excellent. So I'm going to make this just the color red, so it's a little easier to talk about. So I have this feature, and then I also have some metric that tells me how good this feature is. And I'm just going to say coming up with metrics is really hard and really important to get right. So I'm going to cheat and just assume that I have some great metric that does everything I want. When it goes up, that means the site is doing better. If it goes down, it's doing worse. So now I have this feature, I have this metric, and now I kind of brainstorm ideas of how I can make that metric go up. Maybe if I change the feed from red to blue, we can make the metric go up. So now we have a question. Does the color make a difference? And this can be answered with an experiment. One type of experiment that works really well for these kinds of things is an A/B test. In this one, we're going to randomly show half of visitors red, half of visitors blue, then run some statistics on our metric. Now we get to the part where we're going to write some code. So we're going to implement our variants, or implement the 2 different versions of the site we want to do. And at this point, I'm making an assumption. I'm assuming that I can have both versions of the site running, and then just choose between which version to show on the fly. Then to do this, all I need to do is write some code that does the random assignment, chooses which version of the site to show. Cool, and then part of the code that I need to write is some code that does the experiment assignment. This whole talk is about that, so I'm going to get back to that in a moment. So finally, we're going to start to run our experiment, collect some data, run our statistics, and then we'll be able to answer our question, does the color make a difference? Cool, so with that, we kind of have our first rule, we have kind of an outline. And one thing I want to note is there's a lot of talks about A/B testing that are great, a lot of talks about experiments on the web that are awesome, and they often treat experiment assignment as kind of a black box. And so this talk is kind of doing the inverse. We're going to kind of treat everything else as black boxes, and I'm going to completely focus on for the rest of the talk on how you implement experiment assignment. All right, so I want to introduce one more thing, or talk about one more thing, go into a little bit more detail how we're doing assignment. What I'm going to say is these dots are like our visitors. Then experiment assignment is going to randomly assign every visitor. In this case, how I'm doing it is a visitor will visit the site, I'll flip a coin, depending on the result, I'll show them red or blue. This is another design decision I'm making. This is an online approach. So I don't need to know when visitors come to our site, I don't need to have seen them before, I can assign them. That doesn't really matter. And I'd also just want to note, a lot of the things I'm going to be saying assume that we have enough traffic. So if I forget to mention that later on, just keep in mind the amount of traffic. Like a lot of our assumptions depends on having enough traffic. Cool, so then we're going to end up with this random assignment. OK, so I want to introduce my second rule, which is that we should avoid introducing bias. While we're implementing assignment, we should try not to bias how we're doing assignment. So to do this, I'm going to talk about why we care about randomness so far. So the goal of the A/B test is to answer this question, does the color make a difference? And we could also ask, if we're looking at these two metrics, are we comparing just the effects of the color? So spoilers, we probably aren't unless we're doing random assignment. So let's not randomly assign. Let's do it based off of time. So for 1 week, we'll show red. For the next week, we'll show blue. The issue with this is that we have these unknown variables associated with the week. Maybe it was really raining last week. And we don't know this, but people who were stuck in rainstorms think that our site is a lot less cool. They don't like it as much. So then when we ask, are we comparing just the effects of color? We aren't, because of these unknown variables. We're also comparing the effects of being in a rainstorm versus not being in a rainstorm. So this is what I mean by bias. So I'm highlighting all the users who were stuck in a rainstorm, and you'll notice a lot more of them are in the red box than in the blue box. OK, so real quickly, how can we avoid bias? Let's use random assignment. So now the result is if we look at our unknown variable, it's a little bit more evenly distributed between the two. And when we ask our question, are we comparing just the effects of color, we can more confidently say, for the most part. This is where statistics comes in. And just a note, randomization doesn't, even with randomization and statistics, there's certain cases where it doesn't solve the issue. For example, if your metric is the average number of clicks, and you have some bot on your site that's clicking like crazy, randomization is not going to save you from that bot. So just a heads up, I'm going to talk about how great randomization is, but remember, it doesn't solve all of your issues. Cool, so we randomize to avoid bias from unknown variables. But we can also introduce bias in other ways. So that's why one of my rules is, while we're implementing an experiment assignment, we should avoid introducing bias. Cool, so these are the two rules, and that was kind of my introduction to experiments on the web. So now I want to, let's dive into code. Let's try to write some code that does experiment assignment, or random assignment from scratch. So let's try out random.choice. So first, some setup. So I had this feature. It was the list of reviews. And I'm going to show, I have an endpoint that returns a page of reviews. And I'm also going to say I just have some hard-coded string red, and if I change that string, then it's going to render it as a different color. So this makes it pretty simple. All I need to do is replace that string with this function. And then that function should return either red or blue. OK, so let's do it. Let's use random.choice. Now let's try it out. So we're going to load our first page of reviews. It's red. That seems cool. Now we're going to go to the second page, and suddenly the entire site has changed to the color blue. What is going on? Go to the third page. OK, it's still blue. Maybe things are OK. And then the fourth page, and it's red again. This was not a very good user experience. So why did this happen? It was because we weren't thinking about our experimental units. So in experiment design land, an experimental unit is what we're assigning to the variant. So going back to an earlier image, we can think of each of these dots as an experimental unit. So in this case, the code is calling choose color assignment on every page request, which means our experimental unit is the review page request. And if we highlight all of my visits to the site, I was assigned to multiple cohorts, which was a bad user experience. And in this case, it doesn't work very well for this experiment. OK, so let's try to fix this. So when I was designing this experiment, I naively wanted like a person to see one variant. So if I had it ended up as this red dot, I would think that we had changed the site to red everywhere. If I was on multiple devices, I would think we had changed the site red on all of those. The thing is that we're kind of limited by what information we have in the web request. It's probably a good thing if that the website doesn't know that I, Jessica, have visited this site. We have to kind of approximate it with other things too. So a couple of different ways we could do this. A popular one is like a browser cookie. So within a browser, we'll be assigning you the same thing. If you open up a second browser, we might randomly assign you to something else. If you're on a second device, you might be assigned to something else too. Another thing we could use is something like user ID. So if you're logged in, then we would be able to tell who you are across multiple devices. The thing with this, though, is that we're limiting our experiment to only people who are logged in, which can kind of change what conclusions we can make from our experiment design. So this is kind of a place where we should go back to our experiment design, revise it, say, hey, if we're going to be using user ID, we're only looking at logged in users. So for this, for the rest of the talk, I'm going to use user ID. OK, so this one's kind of a fun example when we look at the rules. In this case, we avoided introducing bias. We randomly assigned perfectly fine. The issue was that we weren't following our experiment design, specifically because the experiment design was kind of vague. It didn't tell us what our experimental unit should be. OK, so let's write some code that actually works. At this point, I'm going to show a particular implementation. This is how we would do it deterministically. So if we drop this function anywhere, it's going to assign the same thing. So I'll take my function. I need to pass in my experimental unit. Then I introduce a second requirement. If I pass in the same user ID, it should return the same thing. And then different user IDs should still be assigned independently, statistically random way. OK, so here's the code that I'm going to use. Cool. OK, I'm going to walk through that now. So first we build this string that contains the user ID and this experiment salt, which is the string color. Then I'm going to call some sort of hash function on this key. So hash function should give us, given the same key, it should give us the same value. Certain hash functions, if we give it a different key, it'll assign in a way that's pseudo-random, but random enough for statistical matters. So this hash function really does helps us with those two requirements. The rest of this code is just kind of turning it into the information that we need. In this case, MD5 happens to work pretty well as our hash function. Then we have two different colors, so we're going to modulo it by 2, and then we're going to use that to index out of this list of colors. And we can try it out. If we use the same user ID, we get the same values. Different user IDs give us different values. And so we did that. With that, we could run an A/B test to run our experiment around figuring out which color is the best. So that's pretty cool. OK, so that was the first random assignment from scratch. Now I want to show you how to extend this in ways that are often needed when you're trying to do this at scale, when you're trying to run more than one experiment at a time. So two things. One, we should keep in mind, or because we're following as long as we're following those rules that I laid out, we're able to do a lot more complicated things. And then another one, I'm going to just kind of introduce all the building blocks and not really go into details about how you can put them together. But I hope that it kind of inspires you to look into this more. OK, so first I want to talk about that experiment salt. So here is my choose color assignment implementation. And that was my experiment salt. And you'll notice it was kind of hard-coded for this assignment. So if I had a second experiment that I wanted to run on the same users, I would update that salt. I would use something different. And so the deal is, the hash function made it so that different user IDs would be independently assigned. By using a salt, we can make it so the same user ID is independently assigned across different experiments. In a way, that, you could also think of it as like, we're making our assignment for the color experiment, then we're shuffling everyone before we're making our second assignment for the size experiment. And one more. So here's the color experiment. If I'm highlighting everyone who was assigned the same thing in the other experiment, they're pretty evenly distributed between the two. Cool, so this is the tool that we can use to help avoid bias. We can start to run more than one experiment on the same set of users. I just want to say you should be careful with this, especially in the case of when you're running more than one experiment on the same users, you can run into issues with experiment interactions. This can cause you to make the wrong decision when you actually do your analysis. OK, so now I want to talk about assignment groups. And what I mean by that is before we had 2 colors, and so we modulo it by 2. What we do instead is that we choose a much larger number. Like, we use 10,000, but you could also use something like 20. And what this gives us is that it takes all of our users, and it randomly assigns them to different groups. And just want to note, it's users, remember, because our code is using user ID. That's our experimental unit. So now we can do a lot of things with this. So one thing we could do, we could run the experiment we were just running before. Now we're taking our 20 slots, we're assigning 10 to red, 10 to blue. But we could do even more. So we could do an 80-20 split, which could be used for like experiment rollout. Like maybe you only want to show 20% of your users a feature first. And what's cool about this is because people stay assigned to the same because people stay assigned to the same group, then but when you move from this to this, we won't be giving people a new feature and then taking that new feature away. There's another way to view the same thing, though. We could also say that this 60% of users here are never going to be experimented on. They're only going to receive like the winning assignment from the group that's actually being experimented on. So we can start to build these more complicated systems. We can set users aside and experiment on the rest. We could also split into more than 2 groups. So we could split into like 4, test out 4 different colors. Or we could say we're splitting our assignment groups between 2 different experiments, and then splitting those experiments, then those experiments are assigning their specific assignments. So what's cool about this is any given user is in only one experiment at a time. So now we're splitting traffic between experiments. Yeah, so what's cool about assignment groups is because they're randomly assigned, they kind of act as interchangeable cross-sections of our site's users. OK, so these 2 things are kind of like used together a lot to build up more complicated systems of being able to like run more than one experiment at a time on your site. You can split up users using assignment groups. You can run the experiments on the same users using salts. Also, if you need to kind of like reset an experiment, you could also update your salt too, because that shuffles everyone. OK, I want to just stop or wrap up by talking about additional logic, because it comes up a lot when you're implementing experiment assignment. It's like, experiment assignment is great, but now I don't actually want to be randomly assigned. Maybe I want like my employees to see the like new feature that we're introducing, to kind of dog food it or something. Or maybe we're like, this experiment should only run on users who aren't from Oregon. Or you could also say, so like here, we're saying users from Oregon are always going to see the color red. We could also put a second experiment there. So we could also start to like split up our traffic according to some attribute and then like run multiple experiments in that way. Also, just a note, like if you do something like this, remember to update your experiment design. Now we might be excluding employees, we might be excluding users from Oregon. OK, so what we're doing, we're selecting some users, we're updating their assignment. Our question is, like, should we allow this, and how can we like analyze it as a result? So we can allow it. One way we could analyze it is like ignoring what they were actually assigned to and just take what they were randomly assigned to. So what's nice about this is the difference between these two groups, they were randomly assigned. So the difference between these two groups are what they would have been assigned to. The thing is that the blue bar also contains a lot of users who weren't actually assigned to the color blue. This will make it harder to detect or quantify my changes, the effects of the change. OK, so it might be tempting to overcorrect for this and start to take what they were actually shown. There's a lot of issues with this, but one of them is that we've introduced bias. All of the Oregon users are now in the red group, and when we compare the two, we're also comparing the effects of being in Oregon. So let's try this one more time. The best way would be to only look at those that were impacted by my experiment. And the reason I wanted to end with this, first of all, this additional assignment logic comes up a lot when you're trying to do this in practice. But also it kind of introduces how these lessons that you kind of learned today can be extended beyond just experiment assignment. A lot of times it's tempting to, or you want to try to get the users that you're analyzing to just be those who were actually exposed to your experiment. But in trying to trim down those users, it's easy to accidentally introduce bias. OK, cool. So that was assignment in practice. I talked about how we can use salts to get independence. I talked about assignment groups and then additional logic. This got kind of complicated. AA tests are a good idea to make sure that you haven't introduced bias in some way. OK, cool. So summary, consider your experimental units, or else you could end up with poor user experience or broken metrics. Here, I showed how to we could implement it in code. And then I showed by implementing it in code, by following those rules, we could sort of expand this to support different ways of running multiple experiments at a time. I work at Yelp. We're hiring. Here's some more information about Yelp. And now if there's time for, or there should be time for questions. Cool. And I think, OK, cool. Do you want, so people should come up to the, or I think you should speak into the microphone. That way everyone can hear you.
So I had a question about the hash function. So you said the MD5 was appropriate. What if you wanted to use a different hash function, or for whatever reason you couldn't use MD5? How do you check to make sure that it's random enough?
Cool, that's a sweet question. So there's a paper that I linked to from my GitHub where they did look at a couple of different hash functions. It's by Kohavi. And they looked at SHA-256, I think, and they tried to run 5 sets of experiments at the same time. And I think they started to find some bias that was introduced at some point. So a ridiculous example is using length as a hash function. Then you run into issues where similar numbers get assigned to the same bucket and stuff. Yeah, so check out the GitHub. There's a link to the article and stuff. Do you want to use the microphone?
So what if the behavior that you're trying to provide variants of is actually rare? Unlike blue screen or blue background or red. What if the actual feature is for example, one search query that you want to modify the behavior to? Splitting 10% is going to be difficult to get enough power in the test. How do you handle that?
Could you say that one more time?
Yeah. So basically, if you're trying to create an A/B test for a feature that is really rarely used by users, and you want to be able to conclude quickly enough, without having an experiment that ends with no effect was detected. How would you do that?
Cool. OK, so if I understand correctly, it's a feature that's pretty rare. So normally you'd have to run the experiment a lot longer in order to collect enough data.
at a search engine and you want to vary just one query, you want to change the behavior for one query, not everybody's going to be using that query, right? Like people are going to be, there'll be many queries. So how do you split the users in a way that gives you an answer within, let's say, a week?
Yeah, definitely. So in that case, like I wouldn't recommend splitting into assignment groups. Like it would be better to be able to use like 100% of users for a case like that. You could kind of use the additional assignment logic that I showed at the end, where you start to split traffic according to like people who hit that query will be in one experiment, and then maybe you have like another experiment that doesn't overlap with that query at all, and you could like reuse that traffic for another experiment too. Oh.
So do you have any general advice on how to handle like non-logged in users? Like any go-tos?
Yeah, okay. Let's see. So anonymous users are kind of tough to do. With user IDs, you get this like really handy identifier. So you can use cookies. Let's see. So I don't think I have very much specific advice besides like you could use cookies and then just like adapt for it in your experiment design. I know that other people have figured out ways to like connect different cookies together, like you're actually the same person, but I don't have any specific advice there.
How did you gather the data?
Let's see, so the question was, how did we gather the data? Yes, that was one of the black boxes that I completely ignored. Yeah, so the data could be collected. You kind of have like the event data of like people actually clicking on things on the site, and then you also have like assignment data, which is like how we assigned you. We need both of those bits of data in order to create those graphs that I showed. The assignment data, what's cool about using a deterministic function is that you don't necessarily need to store that information. You can compute it like on the when you're doing the analysis too. So that's kind of another benefit of using a deterministic function.
What kind of statistical method do you use to compare the results?
Oh man, that was another black box. I'm not going to talk about that. I highly recommend checking out other talks that go into a lot more details, people who know a lot more specifics about that.
And how do you generally measure whether people like red or blue more? What's the metric you use?
Yeah, let's see. I just kind of like, my metric there was just like awesomeness, how awesome the feature was, which was just kind of a made-up metric.
Yeah, but how do you get that data?
How do I what?
How do you get that data?
So you could collect data on like what people are clicking on, or like how many pages people view. Like, there's a lot of different ways you can compute that.
How do you maintain consistency, user experience consistency across platforms? So someone accessing the same thing through their mobile device versus on the web, if you're trying to run an experiment on that?
Yeah, so I think this kind of goes back to that earlier question about like logged out users too. Like if you're logged in, you could use user ID, and then people will be logged in across multiple devices. Otherwise, you might need to be a little bit more creative. Yeah, I heard there's like a separate room that I could.
Yeah, if you want to keep asking questions, feel free to maybe just go in that hallway outside. And yeah, thanks so much. That was great. Really well done.
Awesome. Be sometime at the end. Otherwise, you can find me around the conference. I'll be at the Yelp booth. You can also find me on the internet. And if you go to my GitHub, I have like some supplementary materials on there too, if you want to check it out. My GitHub is just Stringham with 3 S's. So this talk is about implementing random assignment for experiments on the web, such as A/B tests. But this is how I describe it to friends. So first, let's get a show of hands. How many of you have heard of A/B testing? Oh man, that's so many hands, amazing. Great, so this talk is going to be about how do we make a decision given a visitor to show you A or B. And you might be thinking, that seems pretty simple. Why not just use random.choice? And I'm going to say we can do better than random.choice. It helps to learn a couple of rules first, and it gets a lot more complicated when we try to scale it up and try to run more than one experiment at a time. So a little bit about me. I work at Yelp. Yelp's mission is that tells me how good this feature is. And I'm just going to say coming up with metrics is really hard and really important to get right. So I'm going to cheat and just assume that I have some great metric that does everything I want. When it goes up, that means the site is doing better. If it goes down, it's doing worse. So now I have this feature, I have this metric, and now I kind of brainstorm ideas of how I can make that metric go up. Maybe if I change the feed from red to blue, we can make the metric go up. So now we have a question, does the color make a difference? And this can be answered with an experiment. One type of experiment that works really well for these kinds of things is an A/B test. In this one, we're going to randomly show half of visitors red, half of visitors blue, then run some statistics on our metric. Now we get to the part where we're going to write some code. So we're going to implement our variants, or implement the two to connect people with great local businesses. To do this, we run lots of experiments. So for a few years, I helped run experiments. And then more recently, I worked on an experiment assignment library. And in doing this, I worked with a really cool team. I learned a lot from people at Yelp who were running experiments. And then I also did my team did some research about how other people are solving these issues. And we brought this all together to build our experiment assignment library. And I also wrote this talk based off of that information. So I have to say thank you to all those people for helping me with that. So here's the plan. I'm going to start by giving some context and kind of introduce the rules of experiments on the web in general. Then I'm going to show how to implement random assignment from scratch. Then I'm going to show assignment in practice. And this is the part where we start scaling it up, trying to run more than one experiment, which you often need to do if you're actually trying to run experiments. OK, so let's start with experiments on the web. So we're going to start by coming up with some design, so kind of sitting down and thinking about what we want to do. Then we're going to write the code, that's implementation. Part of that is implementing experiment assignment. And then we're going to wait, collect data, and run our analysis and stuff. And I also want to introduce my first rule, which is to follow your experiment design. All that means is that with these steps, all of them kind of need to be in order, be in sync. Otherwise, it kind of all falls apart, and the conclusions we make are incorrect. OK, so let's start with design. So I'm going to have this feature. This is the list of reviews. This is my review of Bob's Red Mill that's down in Milwaukee. So you guys want food? Yeah, Bob's Red Mill, excellent. So I'm going to make this just the color red, so it's a little easier to talk about. So I have this feature, and then I also have some metrics. Experiment assignment on the web.
Okay. Cool. How long have you been doing PyCon?
I don't know, almost a decade? I learned it, yeah, almost a decade, I guess.
Great. Do that. All right. We'll go ahead and get started. All right. Good morning, everyone. We are going to get started now. I just want to welcome everyone to the first talk of the morning. And this is Jessica. She's from Yelp. She's been doing Python for over 10 years and lots of experiments on the web. So she's going to go ahead and get started now. Go ahead and give her a round of applause.
Hello. Can everyone hear me? Sounds like you can. Sweet. So my name is Jessica Stringham. I'm going to be talking about experiment assignment on the web. If you have any questions, there should